The 3-act math lessons are very different than the standard lessons. The students have to do authentic mathematical modeling, identifying the variables, identifying the model they want, and then using that to solve the problem. When teaching a 3-act mathematical modeling lesson, students are going to define the question after seeing the first video. We all agree on what the main question of the lesson is. You can talk to your partner, you can turn and talk. One question you have. Josh, tell me yours.
Why is the elevator on the bottom so much faster?
Sophia?
Which elevator will get to the top first?
The main question today is which elevator will get to the top first. I provide a Post-it for every single student. Have them write down what they believe the answer is and bring it to the board. That investment is crucial. They like being able to make a guess and be able to reflect upon their guess. They like being engaged in the lesson and not being told everything up front. How are we going to figure this out? On question number 5 on your sheet, it says, what information will be useful? And this is getting what Cody said at the beginning. What math will be useful to answer this question? What math do you need to know to answer this question? I want you to talk it out at your tables.
Well, I mean, I guess you have to know the floors per second, I guess, and then you can see how many seconds it would take for each elevator to go to the top. So I suppose you would need division, but that's my guess.
So the first thing that I heard was back at this back table over here. First thing I heard out of Noah. Noah, you said immediately you need to know the what?
The speed of the elevators.
I heard Camden jump in and say what?
How high each elevator is, what floor they're each on.
Right, the floor they started on. Cody, I heard you jump in back there. You need to know what?
The height of each floor, like how big the building is, how many floors.
Total. The total height or number of floors. And then I heard one more interesting one. Go ahead.
How many times the elevator will stop?
How many times the elevator will stop? How many times the elevator will stop? Now, the really interesting thing about that one is we're not going to give it to you because we're going to give you the speed instead. And if we give you the speed, it's going to be the average speed, including the what? Including the stops. Do you see some math yet? All right, I'm going to give you the information now. I'm going to give you 10 minutes to work in your groups, 5 to 10 minutes to work in your groups. Then each group is going to report out their solution. How'd you get that?
The elevator started on the 70 stories.
Uh-huh.
And then elevator B started on 6.
Correct.
And then it goes up by 3.
Correct.
And then you can subtract 6.
Beautiful.
64, and then divide by 3 to get...
Beautiful. It's an excellent job. How about the other elevator? How long did that take?
I didn't get that.
Brianna, how long did that take?
30 seconds.
30 seconds. What'd you solve?
1x plus 40 equals 70.
Very good. Who wins?
B.
B does win. Yeah. How do you know that's the express one?
Because it started on the 6th floor and it goes up 3 times.
Right. So who does win?
The B one.
B, because it took how long?
21 seconds.
And A took how long?
30 seconds.
30 seconds. Okay. Now, I got 2 follow-up questions for you. Follow-up question number 1. When do the elevators on the same floor? And then I'd like you to see if you can graph it. It makes the kids see that the mathematics they are learning does occur in real-world situations. They have to come up with their own model. They have to use mathematics in an authentic sense, the way engineers do, the way computer scientists do, the way people do in STEM professions. The most exciting thing to me about a 3-act lesson was at the end. The kids were coming up with that the express elevator was getting there faster. They did it many different ways. Some kids went directly to the algebra they had learned previously, and other kids used numerical methods with no algebra whatsoever. But talk us through your work, Lisa.
For A, it was 1 floor per second, and for B, it was 3 floors per second. We subtracted our our starting point from how many stories we started with. It took 30 seconds for A to get there and 21 seconds for B, so B will get there first.
Excellent job. Let me follow up with that for a second. What you put right here is A has 30 floors left. How'd you get that 30 floors left?
What we did was we subtracted the 40, where our starting point, from how many stories there actually are.
And then how'd you get from 30 floors left on A to 30 seconds?
It takes a second per floor.
Excellent. On B, how'd you get your 64?
64, we subtracted 6 from 70, which is how many floors there we started with.
And then how'd you go from 64 to 21 and a third?
We divided by 3, which is how many floors per second it is, to get how many seconds it would take.
Nisa, that's wonderful. And then clearly B gets there what?
Faster.
Faster. It's amazing work. And I just want to point out something here, guys. I don't see any algebra up there. Do you see any variables? But it's still amazing work. And actually, she is doing algebra. She actually is taking 70 minus 6 and getting to 64 and then dividing by 3 to get her 21.3. Nisa, great work. All right, go ahead, Marissa.
Okay, so the first thing we had to do was find out the speed of the elevators. And using these tables, we figured out that for A, it's 1 floor per second, and for B, it's 3 floors per second.
Okay, then what?
Then we put them into these equations. We subtracted 6, which we got 64, and then we divided by 3, and we ended up getting 21.33.
Stop for a second there. Do you guys realize that's exactly what Nisa did? Remember how I said a second ago, Nisa subtracted 6 and then divided by 3? The only thing Nisa didn't have was this X in here. Didn't set it up algebraically, but I believe still did some algebraics. And then you calculate that what?
That B is faster than A.
Very nice job. Both of those solutions are excellent work. Now the follow-up. One group was going to do the follow-up, okay? Marissa, thank you. 1757. Talk to me about that, Catherine. What's the 17? What's the 57?
After 17 seconds, both elevators meet on the 57th floor.
Beautiful. What was most important and exciting to me was kids were generally happy. Kids were generally excited that they got the answer. And when they saw the video at the end that verified that they were correct, there was real excitement in the room. And I think that's the best part of a 3-act mathematical modeling lesson. So each of the 3-act mathematical modeling lessons lead kids on this journey to mathematical modeling.